What is the greatest number of 3 centimeter cubes that can be cut from a rectangular block of wood measuring 18 centimeter by 10 centimeter by 8 centimeter? So now we no longer fix unit cubes into the wooden block. So notice that this means not unit cubes. So previously every small cube is equal to 1 cubic centimeter. All right, but now we are going to use 3 cm cubes instead. Now we have to use this particular strategy because some 3 cm cubes cannot be cut into smaller pieces. So what do I mean? Okay, let me just very quickly sketch out the cube that we are talking about. Right, the cuboid. So the cuboid is 18 cm by 10 cm by a height of 8 cm. Right, so if we were to place, and this is the concept here, if we were to place 3 cm cubes here like this, how many of such cubes can I place? So we know that 18 divided by 3 gives us 6. So for this kind of question, we need to count the number of exact cube that can be placed onto the length, onto the width or onto the breadth, and onto the height. So let me explain the next part. What about putting cubes and stacking them up along the height? We know that if we put a 3 here, the next one will reach a height of 6, and the last one would have reached a height of 9 if we place 3. And 9 will cause this cube to be jutting outwards. But that's not how we can cut the small 3 cm cubes from. So the number of small cubes that can be cut from the height of the wooden block is not 3 but 2. Not 3 but 2. How do we get this magical number 2? We get this magical number 2 from 8 divided by 3. So the 8 is the height divided by 3, the number of 3 cm cubes that can form within the height, and that gives us 2. Let us try again with the breadth. 10 cm. How many 3 cm cubes can be formed along the breadth? We have 3, 3 plus 3, 6, 6 plus 3, 9, and then we are going to get a 1 centimeter gap. Okay, so we're going to have a 3, 3, 3, and then we are going to have a gap here that the 3 cm cube cannot form. So how many cubes can we cut from the width? 3. Okay, so what is the total number of cubes that can be cut? The total number of cubes can be cut would be 6 cubes along the length, 3 cubes along the breadth, and 2 cubes along the height. And that gives us 6 times 3 times 2, 36. Henceforth, the greatest number of cubes. What kind of cubes? 3 centimeter cubes that can be cut is 36. And that is example number 2. With the example of example 2, let us now look at question number 3. All right, question number 3 is in a similar style. What is the maximum number of 4 centimeter cubes that can be fitted into a rectangular tank measuring 15 cm by 9 cm by 8 cm. So previously we split up to find the number of cubes that can be found at the length, the number of cubes that can be found at the breadth, and the number of cubes that can be found at the height. Right, so what's the maximum number of 4 centimeter cubes along a length of 15 cm? How many 4s can be formed? So we can do a simple sketch because the number is rather small. It's 4, 8, 12, 16. So 4, 8, 12. The next one will be 16, which is more than 15. And that tells us that the maximum number of 4 cm cubes that can be formed along the length is 3. How about the breadth? We change back to black. So the breadth is 9 cm. So how many 4 cm can I have? 4, 8, and then we know that anything more it will exceed 9, and that gives us 2. And in the final example, we have a height of 8 cm. So how many 4 cm can be found? That's quite obvious. 4 and 4, 8, and that gives us 2. So this is a perfect fit for the height. Okay, but it's not perfect fit for the breadth and the length. So it gives some space. So what's a space that are unused? There is unused. It's 3 cm. So space, there's a gap of space. There's 3 cm left. How about along the breadth? 9 minus 8, 1 cm. So there's a 1 cm space along. Okay, 1 cm space or 1 cm gap. So now we know that we can have 3 cubes along the length, 2 along the breadth, and 2 along the height. The maximum number of cubes must be then equals to 3 multiplied by 2, 6, multiplied by 2, 6 multiplied by 2, 12. Maximum number of cubes, 12. And that's for question number 3.